Hey guys, I hope you're fine. Welcome to the live class. This topic is very interesting one because that was one of the first tasks I had to do when I was a junior developer. I had a freelance project which involved a lot of images. It was a toy system, a toy exchange system, in which users could upload a lot of toys with a lot of images. And initially, I went with the straightforward way. I implemented the image uploading and the image visualization in a way that was very simple, so to speak. And the whole result was that the website started loading for like 10 seconds on each page. And the website, when you started uploading images, it was like 30 seconds or so to process all the images. So apparently there are a lot of tiny details that we can do to optimize and to make images work better. Because when I did the site, I was very surprised to see that images took a lot of resources, images took a lot of kilobytes, a lot of traffics. When I put the website on online tools to validate the website, I realized that my site was garbage. Well, of course, it had quite a lot of images involved, so it needed that optimization. If you have a normal website, mm, a normal website in which users don't need to generate images, don't need to create and upload images, then it's okay because typically um, normal websites have more like 4 to 5 images per page, which load quite fast. But what happens if you have an image gallery, if you have user-generated images? A website which allows one user to upload an image and all the other users to see that image, for example, like Instagram, then you have to implement a lot of protocols and a lot of tiny details to make that work and to make that as performant as possible. Of course, we're not going to talk how Instagram scales their application because Instagram is quite on a different level. I'm going to talk about the average website. The average website, for example, an ad site, ads for cars, for furnitures, um, for example, a small forum or even an average forum. Uh, for example, a forum like Stack Overflow, if they allow images, how would they process them? So this is what I'm going to cover in this live class, and I'm going to implement most of the solutions by hand manually. I've already created the solution. It's a blank solution, straight ASP.NET Core MVC app with authentication and nothing more. That's the whole app. So we're going to add some features. We're going to add image uploading. We're going to optimize it. We're going to introduce some of the concepts. And I'm going to talk about how to store images in general when we are in a web server, because that's the $1 million question. Uh, where to store the images, where to store the do you use the database, do you store the images in the database, or do you use the file system? And I'm sure that if you go to, let's say, 50 interviews in your town, in your city, most probably at least one guy will ask you this question: where are you going to store images, or where are you going to store files? Of course, the first solution, the obvious solution, the easiest solution is to say in the cloud. I'm going to store in Amazon or some Cloudinary or some other image related clouds, because on Amazon you can use an S3 bucket. I'm going to talk about cloud storage later in the lecture, but you can use an S3 bucket. You can upload images there. It's fast, it's performant. You just need to get the URL, put it in your web page. It's okay. Yeah, but that's working fine. It's optimized, it works on scale, but it's costly. It will cost you a lot of dollars for hosting, and if you have a lot of images, it's not worth to use a cloud in terms of hosting, in terms of prices. Most probably it will be better to use self-hosted solution to store the images on your web server. Of course, that it depends on the budgets of the website, but if you have huge amount of images, maybe it won't worth it if you know how to implement it by yourself. So, two things before we start. First, all the concepts I'm going to talk here are working not only for images, but are working for files in general. So if you have, for example, HR system, if you have applicants who apply with a CV, a motivational letter, some other documents, where to store these documents? On the file system, on the database. Uh, it's the same concept as it is with images. So the concept is the same. If you want to implement a file system of some sort, if you want to have file uploading of some sort, you can do it with the same abstract concepts I'm going to show you here. The second thing is these concepts work well in every server-side technology. Of course, this mentorship program is for ASP.NET Core developers, so our example is with ASP.NET Core, but if for some reason you choose to develop with Node.js in the future, the concepts are the same. Everything is the same. So that's a very interesting topic. I learned a lot because I had to optimize that freelance project because it was not working. The clients were not happy. So I started optimizing, and I optimized up to 10 times by introducing some tiny little concepts here and there. Okay, so I've prepared some slides. They are not very much because we're going to mostly code in Visual Studio, but this is what we're going to cover. This slide just helps me not to forget about something because I want to mention everything possible around images and files in general. And additionally, I've added some helper code here and there, which we don't want to waste time writing it because it will take, what, 20 minutes to write this code, which is just part of some documentation, or if I've already done my research. So, okay, first things first, we have the following requirement. We have users who can upload multiple images. They can upload, for example, up to 10 images. The first problem here is that a lot of users don't care about the image size. They can upload images in a RAW format, they can upload images from their latest iPhone, for example, they can upload images from a professional camera and so on. So they can easily send 100 megabytes in just 5 or 6 images, which is quite a lot. So we need to somehow process these images, because if we store the images in their original format and start serving these images as responses, imagine how bad it will be if we request 10 images and each image to be 10 megabytes, for example, especially on mobile devices. That's 100 megabytes for a single page. It will be slow, and we're going to load the network. And when we are loading the server network, we essentially create a performance issue with the server, because the server network is a limited resource. And if a response takes a lot of time to be delivered, then the server won't be able to serve other responses. Of course, it can serve multiple responses at the same time, but it's a limited resource. So if the response is super slow, we're going to slow down the server, we're going to slow down the client which will render the images, and the whole website will be slow. From server to the network to the client-side rendering, it's not worth it. So the first thing we need to do is we need to restrict the request size. Of course, that depends on the business case, but we need to do it. Okay, I'm going to add some images controller, which will be responsible for processing uploads, returning images, and everything related to images in this web app. So let's create public action result upload. This will be my upload view. Of course, it will be super simple because we don't care about web details. And we need a form. So if you're not super familiar with file uploading, we have an input type file, and we have the option to say multiple files, which essentially means this. Good. The problem here is that by design, multiple files in forms are not supported. We need to add additional enctype attribute, which is something like enctype. I always copy paste it from internet because I can't remember that shit. It's enctype, multipart, form data. Yeah, it's not that much, but I'm stupid. I cannot remember things like that. Then input type submit, and pretty much that's it. Now we have to add some model binding here because this form will send the files. It will send the images. Of course, we can say accept image JPEGs and some other restrictions here, but that's not that important here. Okay, so input type file multiple, and we need to fire the model binding. In order for model binding to work, for the HTTP post method, we need to specify upload, then enumerable iForm file like this, and some name. In order for the files to work, we need to have the same name as this enumerable variable here in the input type file. And this should upload our files, and we will get them here. When we work with multiple files, I prefer working with an array of iForm file because it's easier to check some restrictions. For example, if images.count.length, is more than 10, this model state dot add model error images, you cannot upload more than 10 images, and so on. We can easily validate the files by adding some conditional statements here. The iForm file interface gives me some information about the name of the file, the length of the file. For example, I may have a condition to say I don't want to allow a file to be more than 10 megabytes. So I can check that too. Something like this. If images.any image.length I don't have, because I don't have using system link, I guess. Length is more than 10 megabytes, and 10 megabytes is essentially 10 multiplied by 1024. These are the kilobytes, and multiplied to 1024 again, and these are the bytes. So if we have an image which is bigger than that, we can again add some model state error like this. Images cannot be more than 10 megabytes and so on. I'm going to remove that because we don't care currently about the specific details, because that depends on the business case. And uh, if we have a lot of images, if we have a huge gallery, for example, if our business case is a website which allows for photographers to sell their pictures, then apparently we should allow bigger images with higher quality and so on. But if our website is for memes or something like NIGAC, for example, we may allow smaller images. So it depends. It's important to add validation, but we're not going to focus on the business details about that. Also, I'm not going to visualize this error in the HTML because that's not the scope of the lecture. Another thing which we need to do is we need to set a request size limit, because the way ASP.NET Core works is that it will read the header, the content length header, and it will see how much the files are. For example, it will see that the files are 10 gigabytes, but it will not read the files until we say so. So we can easily short-circuit the request without overriding the server memory. So if a user tries to send us 10 gigabytes of files and we allow only 100 megabytes, for example, the important part here is that these 10 gigabytes will never reach our server. The server will short circuit the requests before that, which is actually a very cool thing. So it's super important to request to add some sort of limitation with this attribute. So we can easily say, I'm not allowing more than 100 megabytes for this request. Always write down megabytes in this form because it's easier to read and you can easily calculate it. Okay, that's bytes, kilobytes, okay, that's megabytes. It's much more easier than writing this number directly. Well, I made a mistake, but again, for example, this is 24 megabytes. I'm not sure that everyone will recognize this value, but 24 multiplied by the kilobytes and then the bytes themselves, it will be better. It's more readable. Also, if you work with dates, you can use var time equals 5 days multiplied by 24 hours multiplied by 60 minutes multiplied by 60 seconds. This is easily readable that it's 5 days. It's very easy to understand that this number represents 5 days. If you calculate that, it will be not that easy. Okay, so we restrict the request by specifying request size limit, and this is super important because if you make the logic here, images dot sum image dot length and so on, it's not that big of a deal, but it's better to short circuit the the whole request as early as possible, because this way the server won't receive any of the huge information sent over the request. So apparently this saves us from some flooding attacks with huge files. Good. So for now, I'm just going to return. Let's follow the best practices. Redirect to action. I'm going to say something like this. And I'm going to add a view. Which will just say images uploaded. Good. Okay, so let's test whether everything is working fine, because we have model binding and we have some validation going on here. So I'm going to run the Castro server. I've prepared a couple of wallpapers, so we're going to test with them. Let me add some links, because we're going to test a lot during this workshop. I'm going to add images controller and upload action. Let's name it upload. So let's choose some files. We have a lot of files here. If we hit submit, we will see request body too large, which is the short circuiting of that request, and that's okay. And apparently, if I hit only 3 images, they will be bound, everything will be fine. So we may continue with our task. Good. I'm going to add to change the validation to be 100 megabytes, because we're going to do a lot of testing with a lot of images and it's better to have more room. Good. So first things first, image uploading. We need to restrict the request size. The second thing we need to do is we need to process the images, because every user will send images in their format. For example, one user will send PNG, the other user will send JPEG, another user will send BMP, and so on. So we need to convert the images to a single format. That's the first thing we need to do. Then the second thing is we need to optimize these images, because if a user sends an image, these are not very small images, but this image is 8 megabytes. If we don't process this wallpaper, when we show the image then on the browser needs to get 8 megabytes only for this image. And this image is huge. This image is quite big. And most probably in the browser, we're going to show it like in a super small box. So the first thing to understand here is we need to understand what sizes do we need, and we need to create different images with different sizes. For example, if our rectangle in which we are going to put our image is 300 by 120, for example, we need to create an image with 300 pixels width, because this way we will save storage, we will save traffic over the network, the browser will render the image as fast as possible because the box is exactly the same, and the users will be happy, and that's super important because it will be super stupid to render an 8 megabytes of image, which is like 4K resolution, in this box. This is a rookie mistake, and I've did it. I've did it in that site, the toy exchange system I mentioned earlier. So it's super important to create images and convert images in the boxes we have on our website. So if we have 3 boxes, let's say that each image is shown in 3 variations. First, a thumbnail, which is super small, let's say 300 pixels. Then a medium size box, which is, let's say, 60 pixels. And finally, if a user clicks on this image, he should see it in, for example, 2K or 2000 pixels of width. So we have 3 boxes in our website. So we need to store 3 versions of the image which is uploaded. First a thumbnail, then a medium-sized image, and finally the full image. And still, our user could upload even bigger images, so we need to optimize them to these 3 versions. And what is important here? It's important to store the original file because we are not sure whether in the future our website will need an even bigger box. For example, let's say that our website evolves, people start using it on smart TVs, and they start using 4K resolutions. It's the new standard, and suddenly all our images look bad. People open it on newer computers and the images look bad. They look distorted. So the solution is to store the original image too, because if we need to create another version of that image, we can use the original, because most probably the original will be with the highest quality compared to the other boxes we've created. So for the sake of simplicity, I'm going to create 2 versions of the images. One will be 300 pixels for a thumbnail version, and the other will be bigger, for example, 1000 pixels. But you need to analyze your website. You need to analyze your, for example, if we have softuni.org, you need to analyze all the image boxes. For example, this is not an optimized image, I'm sure, because we can see that it's almost 1000 pixels. So this image can be optimized. We don't do, currently on this site, we don't do any image processing because the normal users, the clients, don't upload images. So apparently the site has like 6 or 7 images which are uploaded by the administrators. So it's okay. But if we have user-generated content, an app like Instagram, an app like 9gag, an app like ImageGur, I'm not sure how to read that, ImageGur, like this. These apps needs to optimize the images, otherwise they're going to be in a huge trouble. So the thing is, you need to measure the boxes. It's super easy. You can see that this box is 300 pixels. So okay, my image will be, for example, 400, so that it will be not super distorted, but an image of 1000 pixels is too much for this simple box here. Of course, if we click it, it will show us a bigger version of the image, and that's completely okay. But the thing is, we need to create 2 versions, one for the thumbnail and one for the bigger box, and we need to serve the version that is responsible for the current web page, that is needed in the current web page. So that's important. This way you will save a lot of traffic, and consider this: saving traffic and kilobytes over the network first saves you some bills for hosting, for example, and then saves you some CPU and memory on the server. And more CPU and memory on the server means more requests served. So with the with a simple hardware, you can do more requests if you optimize your images, because images are the biggest asset of the web. Of course, videos are bigger, but most probably, and most websites don't have videos which are self-hosted. Usually videos are hosted on YouTube, on Vimeo, on some other clouds, and unless your business in general is related to video playback, you don't care about video assets. You care about uh, images. So the images are the biggest assets typically on a web page if we don't count uh, the businesses which work with a lot of videos like YouTube, for example. So if we hit play here, we can see that this video is hosted on YouTube, so we don't care about it. But these images, this image is hosted on softuni.org. So these images here are self-hosted and we should optimize them. The video is optimized by YouTube, so we don't care about it. Okay, good. I talked a lot, but it's super important to understand that we need first to process the images to have multiple to have the same results if we want to use JPEGs, and JPEGs are the perfect web format, so I suggest them. If the user uploads bitmaps, PNGs, convert them to JPEGs, first things first. Then we need to convert different versions of the image for the different boxes on our website. And finally, we should store the original too, because our website may evolve and suddenly we may need a new version of the images. And if we don't have the original, we will be limited. Okay, so first, the NuGet package we are going to need, it's a library called ImageSharp. It's very easy to use. Library ImageSharp 6 labels. This is what we need to process images. There's a middleware for serving images, but we don't care about that. We're going to serve images. Manually by using super optimized techniques. Good. So the image is received on the server, and we have the length of the image, the name of the image, the file name of the image. So this is the form field name, which will be just images, so we don't care about that. But the file name will be the exact file name which the user sent. We may store that for additional data if we need to mine the images, for example, in the future. So it's a good idea to store this. It's a good idea to store these images, but nevertheless. So the image comes in the form of a stream. So we have two options here. The first option is to use byte arrays. Extracting a byte array from an image, from a stream, is done by creating a memory stream. I'm going to show this approach, even though it's not optimal. And we can do something like copy to memory stream. And then from the memory stream, we can get byte array. And with the byte array, we can do whatever we like. This is the image in byte form. The problem here, the problem with this approach, it's not bad, but we can do it in a better way. The problem with this approach is like moving parts from point A to point B. Let's say that we have 10 boxes to move from point A to point B. These are some boxes full of stuff, and we need to move them to point B. Let's consider that the boxes are not heavy, so we can move them quite easily from A to B. But instead of that, we do it like this. We catch the first one, we move it here, then we return to A, catch the second one, move it here, then return to A, catch the third one, and so on. So we move the boxes half our path, then we move the boxes again to B. So the overall pathing is go to the middle, go backwards, go to the middle, go backwards. Instead of go to B, go backwards, go to B, go backwards. It's double the work and it's unnecessary. We don't need to do that. So with streams, if we convert the stream to a byte array first and then process it, we are essentially doing this. It's not bad, but we can do it more optimally. We can say, hey, this is the stream from the network. Just start using it. Just start processing it. And this way we're going to skip the middleman by not creating a byte array. Of course, in some situations we may be forced to create a byte array, but if we can work with streams, that will be the better approach. So I'm showing how to extract the byte array from the image, but there's a better way. I'm going to add image service, some interface here, and I'm going to say public void process, and I'm going to receive an image input model. It's a bad separation of concerns to say iForm file here. This is not a good approach because the service should have business logic and only business logic, and here we have web related stuff, we have HTTP related stuff, so this is wrong conceptually. So we need to provide an image input model. So I'm going to add image input model, then I'm going to say the image has file name, some string file name, type of the image, and it will have a stream content. Of course, if streams are difficult for you, you can use byte array here and work with byte arrays. It's a small overhead. It won't change your performance that much, but I'm trying to give you the fastest possible solution without going too low level. So I'm going to give you the middle ground, a solution which performs very well and it's not that difficult to implement, because I'm going to show you another approach in a minute which is kind of hard to implement, but nevertheless we will see it in a minute. So let's say that I have a enumerable of image input model images like this. So let's implement that. Image service. Image service. I'm going to need image sharp in a minute, and let's register the service here. Services add transient image service maps to image service, like this. Good. Go to the controller, inject the service. And just say image service dot process images dot select. Each image should be mapped to image input model. The file name is image file name. We're not working with files, so I'm going to rename it to name. Let's make it more abstract. Like I said, these concepts work with files in general. It doesn't matter whether the files are images or something else. Most of these concepts are pretty much the same. Image.content type, and content is image open read stream, like this. So we are done with the upload methods. We just need to implement the image service. So implementing the images, the straightforward solution is create for each image, transform it, use image sharp to transform it. So I'm going to say using image sharp, like this. The transformation is super easy because image sharp allows us to say something like image result equals the image class coming from image sharp allows us to say image.load, and we can provide a stream or byte array. So if you decide to use a byte array, that's completely fine. But with a stream, it will be more optimized. And it's not more difficult because once I pass the content here, which is essentially the stream of the image, everything is completely fine. The cool part about image sharp is that it will automatically understand whether image is a bitmap image, whether it's a JPEG, PNG, so it doesn't matter. We don't need to check that. Then I can say image result mutate and say image dot resize, image dot change something, and various different operations. I can do a lot of stuff here. Auto orient, background color, black white, some blur effects, brightness, and so on. But we don't care about that. We want to show the images in the same the images should look the same, so we just need to optimize them. Of course, if your business requirements say something like we need to convert the images to black and white versions of them or something like that, you can use image sharp to do that. So okay, what we need to do is we need to get the original width, which is image result width, and original height, which is image result height. Image result height, like this. And we need to fix the boxes. What we're going to do is we're going to resize the image to certain width, but we're going to maintain the aspect ratio. So the height will be calculated based on the width difference. So we won't be we won't be specifying the height, we are going to calculate it. But let's say private const int thumbnail width will be 300 pixels and private const int full screen width will be 1000 pixels. I told you that I'm going to use only 2 versions, but nevertheless, let me check how full screen is written. It's one word, I believe. Yeah, it should be. Okay, so what we can do here is we can calculate the height. I've already done that here, so let's see how we can do everything. We need to get the original width and the original height. Then we're going to resize the image only if the width of the image is bigger. If we have a box of 300 pixels and the user uploads 200 pixels image, we don't need to resize it. It will distort it and we're going to make the image bigger, and that's not our goal here. We want to make the images as small as possible. Of course, if the thumbnail is 300 pixels and for the box and a user sends us 200 pixels, maybe we should return an error and tell him to upload a better image. But that's not the case. That's not important here. That's again validation. But it's important to not process image if it's not bigger than the resize. Then what we do is we calculate the height. Calculate the height is by doing some math. First, we need to see the aspect ratio of the resizing. So if it's 0.9, we need to multiply that to the height. So this will be calculated because we want to save the... I'm going to say like that, width, height. And here what I need to do is I need to say, okay, I want the full screen width, the full screen width, the full screen width, something like this. And then there is nothing specific. We can save that to a byte array. We can extract the image as a stream, whatever works. Whatever works, whatever our storage option supports. Good, and I just need to specify the resizing here. And I need to say new size with height, like this. Good. This will resize the image to a specific width and specific height. Then in the image result, I can say save as JPEG, like this, and I can provide the JPEG encoder options, and I can work with the quality here. So I'm going to need a stream or a path here. So it depends on the solution. So for now, I'm just going to say save the image to image.name to make sure whether everything works. And then I'm going to say I want a new JPEG encoder with quality of 75. For web formats, 75 is kind of okay. You will see it in a minute. It looks nice. It's okay. It's a good ratio of quality and size. If you are working with a business which is for photographers, maybe you will need to store the image in the original quality. Because the default value is 70, I'm improving it a bit, but for very high quality images, if you are selling pictures on your website, then the quality should be bigger. So that depends on the business scenario. We can also, I'm not sure where it was, let me check it. Image sharp Exif Data. Yep. So Exif Data is some data about the image, and it's a bit tricky because image result metadata exif profile exif the exif profile of the image stores information about the image geolocation, the image device, some other information, for example, the date time of the image and so on. So consider that it's important to remove that image because you may leak personal information. If you store the EXIF profile in the image and you don't remove it, you may leak personal information. If you download, for example, analyze EXIF data from image, we can try some of these wallpapers to see what will happen. I'm going to post camera info not found, copyright not found, GPS coordination, but you can see that if I make an image with my phone and I upload it on a website, and if the website doesn't remove the EXIF data, this is some personal information, so it can be used against you. So if you care about your users, you should remove the EXIF data. I guess we can see that this image was designed with Adobe Photoshop on Windows. I guess you understood, but let's try with another image to see what's going on. But all my images are Photoshop. They are designs. They are from the StarCraft game. So okay, most of them won't have camera, I guess, but that doesn't matter. Double full screen width. Okay, that doesn't matter. Double resize width, you mean? Okay, yeah. That's not a bad adjustment. Good. So the EXIF data should be removed. The quality is important and it depends on the business case, but 75 is good for the web. If you want to be more quality oriented, 80 should be fine. Okay, so save the image. What we can do here is try whether this works. And I'm going to run the web server. Let me fix the double thingy here too. It was a good remark. So let's choose 3 images. Let's submit them. And images uploaded. And they should be in the main folder. So they were resized and they look completely okay. They are not squished or distorted or anything like that. They are just smaller versions of these very beautiful wallpapers of the game. Okay, so this is working fine, but that's one part of the problem. Let's try to see how much time it takes us to upload 10 images and to resize 10 images. Unfortunately, most of the images are quite optimized already. This is a bigger image, 8 megabytes. All of the others are kind of small. So let's make more of the bigger image, and let's try to flood the server with a valid request, because we are essentially uploading more images, but all of them are big with huge resolution. Let's see how much time it will take our server to process them. It took him like 5 to 10 seconds. Keep in mind that this is localhost and this machine is super fast, but 5 to 10 seconds is still slow. Imagine 1000 users uploading this much images. Our server will have a hard time. Of course, the resizing works great because the images are now small. Let's see how it looks. It looks okay for 1000 pixels. I believe the quality is good enough. Of course, it's not 4K, but we're using web images. Good. So this is okay, but we have the problem of processing images one by one. That's the problem. So let's do asynchronous processing. The first optimization we can do is using streams and not byte arrays, because I already told you, instead of moving boxes 2 times from here to here, from A to B by moving through C, we can do the movement directly. This is what streams are. Of course, with some of the approaches we are going to see in a minute, we may need to convert some of the images to byte arrays, and that's completely fine. It's not that bad, but I'm trying to show you the most optimized versions. So the next thing is optimize the process. Oh, no. Wait a minute. We are not ready, because first we need to have multiple results. We need to have a thumbnail, we need to have a full screen, and we need to store the original too. So basically, this is just copy pasted, but I'm not going to copy paste it. Of course, I'm going to say private void save image, and I'm going to put the logic here. I will need to provide the image itself. Then I will need to copy paste this too. Image width, image height, good. This is the image. I will need to pass the name, apparently, which will be changed to something else in a minute. And I will need to send the size, int resize width, which will be full screen width, full screen width, full screen width. And that's pretty much it. So let's save the image with the new method. Let's do it. First, save the image with in the image result with the image name. Let's do it like this. Let's make it original underscore image name, and then let's provide the original width. So don't resize it, pretty much. Then I want to do the same thing 3 times, and keep in mind that if you have a lot of versions, for example, for the toy exchange system, I converted the image 5 times because I showed the images on various places on the website. So it's important. Then we have the full screen. And then we have the thumbnail. See how I convert the image from the biggest to the smallest, because when I mutate the image, it will become smaller and smaller and smaller. So I need to start with the bigger image. Okay, so I guess it's obvious that if I run now the server and upload 8 images of 8 megabytes, it will take quite some time to process them, because now I have three versions of each image. You can see that it's creating them. Images uploaded. So it's not bad, of course, but still this is localhost, and the website has one concurrent user, which is quite a lot. So let me just delete everything and try not to delete my web server. Good. Okay, so the next thing we can do is, instead of processing image by image, one by one, in a sequential manner, we can process it in an asynchronous manner. So we can introduce tasks, and I promise you that it won't be that difficult. Even if you're not familiar with asynchronous programming, you will be able to understand what's going on. Most of it. But you know, I have lectures about async await, so you can watch them. We need to convert that action to async and await this method here. And then we need to convert the processing of the images to be asynchronous. So what I can do here is I can say var tasks equal new list of task. Then I can say tasks dot add task dot run, and I can specify create a task for each image, and then I can say await task when all. This essentially means that I want all my tasks, I want all my images to be run asynchronously, but I want to wait for all of them to finish. So instead of processing the first one, then the second one, then the third one, I will put on each CPU an image to be processed at the same time. So this will be done, but this one will be already started, and it will be done, then this one will finish, and so on. So all the images will be processed concurrently, and that's super optimal, especially on a server machine which has a lot of CPUs. For example, 24. ReSharper suggests something. Let me see whether it's ugly or not. It's doable. I like it. Okay. Image Sharp has async versions of the method, so I'm going to make everything as asynchronous as possible, because that will be as optimized as possible. We have save as JPEG async, so this needs to be awaited. This needs to be async task. Mutate doesn't have an async. Okay. Save as JPEG, and this should be awaited. Good. So pretty much Everything is fine. Let's try it. Let's see whether we broke something. And then I'm going to make a 5-minute break, and we're going to move to the next part, which is storing the images. So let's try with these Asus again, and let's see how many times it will take. It was a bit faster. It's not 10 seconds for sure, it's more like 3 or 4 for 9 images which have a lot of which are quite huge. 8 megabytes, it's okay. This is the most optimized version of the processing we can do if we're self-hosting the images. For average images, it's good enough. If we select, for example, this, we can see that it's super fast because the images are not that big. Okay, so let's delete the full screen, the originals, and the thumbnails. Keep in mind that with multiple concurrent users uploading at the same time, this approach with the tasks will scale better. Always consider that adding tasks has the same graph, have the following graph. If we have the performance here and the users here, so the concurrent tasks at the same time, if we do everything synchronously, without task, without threads, without anything like that, the performance will look something like this. The more users, the harder it will be for our computer to calculate the images, tasks, whatever. If we have tasks and asynchronous programming, the graph will look like this. Something like this. Of course, the graph is not on scale, but it proves the point. The point is that when you have blocking operations, so synchronous code, with less users, it's faster because the CPUs have enough power to process everything. But when the users are too much, the CPU starts to, every blocking operation starts to lose power, lose processor time and so on. But with asynchronous code, with smaller users, for example 1 or 2, we have the problem of threads. So adding threads and tasks is an overhead. So adding an overhead to a single task, to a single image, is apparently worse than without the task or the thread. But when we have concurrent users uploading a lot of images, then we will see a lot of performance improvements because the CPUs are utilized as optimally as possible. We don't have any blocking operations like in the synchronous code. So this code is better in terms of performance. We saw that it was a bit faster, maybe like 40%, I'm not sure, but if you measure it, you can easily measure it by using some tool. I believe in one of my coded up events I measured exactly image processing, and it was like 40% faster. So even if you don't trust the code here, you can always measure it. Okay, good. So what we did with image processing is we used streams instead of byte arrays. That saves first memory of the server, because if a user uploads 8 images each, and each image is at least 10 megabytes, then we will have 80 megabytes in memory automatically. And with streams, we will have these 80 megabytes chunk by chunk processed and saved to the hard drive. So it will be more optimal in terms of memory. and it will be faster because we don't need to convert one thing to another. Essentially, without using, let me explain that again. This is the network and bytes come from here. The first byte, the second byte, so on. Some zeros and ones. If we decide to convert these bytes to a byte array, what we need to do is we need to allocate in our RAM a byte array and fill the zeros and ones here. And then our image sharp will get these zeros and ones from the RAM and we'll start working with them. So we're essentially filling 80 megabytes or more, depends on the concurrent users, of course. But with streams, we skip that step and say, hey man, we have some zeros and ones for you. Get them chunk by chunk. So the zeros and ones are processed at the same time they are received from the network, and it's faster this way. And we save some memory, of course. Good. Then using image sharp because it's easy. Asynchronous processing, we're going to see the scopes in a minute. What is a scope? Because with this approach, database contexts don't work, and that's a problem. And finally, we need to have multiple results. We store the original for the future because we may need it, but then we have multiple results. For each box on our website, we create a version of the image. And that's pretty much it. You can register image service as a single instance. As a singleton, you mean? Why? You can rename method process to processing. Yeah, that's okay. How to change default directory where images. We're going to see that in a minute. Good point for double. Yep, I like that. I've missed that when I prepared the class. Well, I'm not quite sure about the whole async methods. In my opinion, if your API doesn't have a synchronous version, you may omit the async suffix. Of course, that's a matter of opinion. And in terms of good practices, because you know how much I care about good practices, best practices. You can see we extract services here. I try to follow best practices, even though this lesson is not about that. I put using in the namespace and so on. The practices I like to follow, I always try to follow them during a lesson. But with the async suffix, it's a bit difficult and it's a bit strange because otherwise we need to put async here too, upload async. And the URL of the method is not upload async. So if I follow these practices by the book, I need to put async everywhere. In my opinion, it's good to follow the same practices throughout the project. That's the most important thing. If you put async on async methods, put it. That's completely fine. But I believe it's also okay if you don't provide a synchronous API, then it's not needed to put the async suffix. Also, the async suffix, in my opinion, is needed in libraries the most because usually your code doesn't. Your code is here. You can see it. You can see that it uses a task, but the library code is more difficult to see. It's not your code. You don't understand it that well, so it needs to scream what it does. And if my web server, the web server is completely async await, it's completely asynchronous, the whole web server, every single action is asynchronous, that means that I have to put async suffix on every single method. And I'm not sure whether that brings any value. It will bring value if I have a method which is synchronous and a method which is asynchronous, and it will bring value if I build a library. This is my opinion, and I'm sure some of you may disagree with it. That's completely okay. The important part here is if you decide to follow a practice, follow it throughout the project, the whole project. But I guess it's a bit strange to have every single method suffixed with async. Tell me what do you think during the break, because I'm not sure if the whole web server is asynchronous, then I have to put async on every method, every single method in my app, from start to finish, from beginning to end. And that doesn't bring any value. That's my point. It just adds a bit of clutter. The image service is stateless. Singleton services should be singleton services are the ones who are stateful by design. If you have state, you create a singleton service because you want all of these objects to be garbage collected. I'm not sure here whether whether you're correct or whether I'm correct. Because we may argue about whether singletons should be every stateless service or not. But if I take a look at the source code of the ASP.NET Core framework, they put everything as transient as possible. The only singleton service they put is a service which has a state, for example, some internal cache or something like that. And they do that because they want to have less memory impact of the server. That's their case. Creating objects is not expensive. So if you want to have more memory, I guess it's an interesting question whether to put that as a singleton or as a transient. The ASP.NET Core team put everything as transient service unless it has a state. You also have a point because we don't need to create this service every single time it's requested, but still. If we follow their practices, they have some points, and that's we want to have as low memory footprint as possible throughout the requests. But nevertheless. Okay, let's make 5-minute break and we're going to continue. Now it will be 5, so don't mother the timer. When it hits 5, I'm going to be here. I hope. So let's wait some 10 to 15 seconds and we're going to continue. So let's continue. While I was on a break, I searched about the topic we talked earlier, about whether the image service should be stateless or should be stateful, and whether it should be a singleton or not. And this topic explains my point of view and apparently the development team of ASP.NET Core, because it won't impact performance as much, and transient scope is better when resource usage is temporary and of minimal impact. If you're only doing compute, for instance, that can be transient scope because you're not exhausting anything by having multiple copies. What we're doing here. Singletons are best when you are utilizing limited resources like sockets and connections. If you end up having to create a new socket every time the service is injected, then we'll quickly run out of sockets, and then performance really will be impacted. So a transient scope is preferred, and it will have less memory footprint, and it's more about not that much about performance, but it will be more about the usage and what you have inside. So currently we have only computational things here. We don't have anything else. And besides that, we're going to inject the database in a minute, and the database cannot be a singleton instance. So it's not a good idea to have a singleton here because of the database. Otherwise it will work, but considering the small research, maybe the ASP.NET Core team is doing the right thing. Let me see. What do you think about additional security checks when uploading files, not especially about images? Well, that's completely okay if you have a lot of if you're scared that something may happen. But typically image sharp will throw an exception, so we can wrap this method here, this task here, we can wrap it in an exception. And if the user tries to upload something that is not an image and it's not working as an image, this will throw an exception. So scanning the files, it depends on the business case. It depends on what we are doing with the files. If the image is valid, it's not important to scan them. It depends on the business case and what we're doing with these images. And the library will throw an error. So if you catch an exception, just don't store the image. That's good enough. But if you have a file upload with zip files, with PDFs, with various other types, and it's not an image, and you cannot check whether the file is an image, then use Quote to scan the file for you. Then it's important, then it's super important. If the user can upload whatever he likes, then it's super important, especially if you serve these files to other users. But for images, the image libraries validate the images, so that's completely fine. This is why I didn't check the image content type, because first, it can be easily forged. So a malicious attacker may send a content type of image JPEG, but the file may have something else. I didn't make that check because it doesn't bring any value. And additionally, the image service will check whether the image is valid. So the only validation here is just one try catch. And I should just put some logger or whatever other mechanism I want to show. I may cancel the tasks, I may delete the processed image, whatever I like. It doesn't matter. Just catching a silent exception is also okay. It means that from 9 images, 1 was corrupt and the other 8 are okay. If the business case allows that, it's okay. If the business case says if one of the files is corrupt, don't process the others, then you need to delete them. It depends on the case, but a try catch, let's add a try catch just for the sake of it. We can use some logger here. Empty general catch, yeah. Log information. Good. I'm super happy that more people joined the mentorship program because now we have a discussion. We discuss advanced topics. We discuss whether we should follow some of the best practices. We discuss stateless stateful services. These are advanced topics and they make you think. Even if I don't have the answers to them, I immediately try to research them and see what's going on. So it's very nice that a lot of people are joining the live classes because usually there are 2-3 people who watch online, don't ask too much questions, and most of the people watch the recording. So it's not very, it doesn't have a good discussion. And currently I'm super excited because people ask questions and the questions are meaningful. Yeah, but most people prefer recordings because nobody, or at least not a lot of people, have 4 hours to delegate for a live class. They prefer to split it throughout the week or something like that. Some of them prefer to watch it on a faster speed, for example, 1.5 and so on. So I understand them, but it's good to have a discussion. Okay, so let's continue with storing the images. The first question is where to store the images. Should we store them in the database or should we store them in the file system? Is there a correct answer? And there is none. So storing images in the database or files in the database and storing images or files on the file system are both correct choices, and it depends. The pros of the file system is that it's faster because it's indexed by the operational system. So it's faster in terms of performance with the images. It's way faster to use the file system instead of the database, because on the database you need to have a database connection, you need to query the database, you have some overhead. But the file system, you need to organize it manually because it will become slower and slower, and I'm going to show you what I mean. And the file system won't make backups. You need to run a background service to backup your images. And it depends on the business case, but most of the time images and files are important to the business, so you need to have some backup. So if you decide to store the images in the file system, then you need to write additional code to backup these images or use an external tool or some other thing. You need to use something to backup these images. Of course, if you are storing the avatars of a forum, and if you lose the avatars, that's not the core business of the forum. The core business are the topics, the threads, the comments. So if you lose them, yeah, people won't be happy, but they don't care. They will upload a new avatar. But for example, let's say you have an HR system, a human resources system, and you lose all the documents of the employees. That will be very bad. So storing data in the file system is good in terms of performance, but it's bad in terms of backups and in terms of organization. You need to manually organize the files. Storing images in a database or files in the database has automatic backups. It has streaming supported, so we can optimize it, and it's not that bad in terms of performance. So, in my opinion, if you don't want the fastest performance possible, you can store the images in the database. It will be easier in terms of development. And if you want the fastest performance possible, you may consider the cloud. Storing images externally in the cloud is super easy, but it costs you money. It costs you way more money than the hard drive of the local system. Because, okay, you will have to buy 1 terabyte of SSD hard drive for the images for the self-hosted solution, but you will do it once, and that's it. But storing a lot of images in the cloud will be expensive in the long run, so it depends on the budget. I'm going to show a sample code of how to store images in Amazon S3. I used it in one of my projects back in the day, 5 years ago, so I'm going to show that. But so we're not going to write cloud-related storage because it's just reading the documentation and following some tutorials. So it's not that important. What we want to learn here is to learn the tiny details of image processing and image storing when we self-host the solution. Okay, so storing images in the database. To store the image in the database, it's not something super difficult to do. We need to have image data. We need to have some ID. Now, the question here is whether to use an integer or a GUID. And what's the difference? GUIDs are generally slower than integers by the database indexes. So searching by GUID is slower in terms of performance and in terms of scalability. So if we put a GUID here, it will be slower. But if we put an integer, we will have the following problem. Our images URLs will be images/1, then images/2, then images/3. And that's a problem. That's problematic because someone can write a bot and can easily extract all the images just by using these numbers. So what we can do here is if we use integers, I'm going to use GUIDs because they're easier and their performance impact is not that much, but I'm saying it if you want to improve it even further. But if you use integers, what you can do is you can make something like this. You can get the ID of the image, then you can do MD5, the MD5 algorithm on top of it. Then you can do the MD5 algorithm on top of that with some secret that only you know, for example, magic unicorns, something like that. So you generate a hash from the ID of the image with double MD5 by using this secret, which only the server knows. Then you will receive something very long. You will cut the first 10 characters. For example, let's say that these are 10, they are 10. You will cut that and you will append them here. So if somebody tries to extract the image by the integer, he won't know the secret here, which was used to generate the hash. And this way your image will be protected and you will have a performance improvement by using integers and not GUIDs. How to validate whether the request was valid? Well, you will receive the ID and you will receive the hash. You will again run that algorithm on the ID with the same secret. You will receive again a long hash and you will compare the first 10 characters. If these 10 characters are the same, then the request is valid. That's how you can save your images from bots by using hashes and integers. Good. I'm going to use GUIDs and I'm going to leave in the code if int id use md5 of the id to protect against bots. Good. So we need to store every single version of the image: original content, thumbnail content, and full screen content. These three. Then what we need to do, we may store the original type, we may store the original file name. That's completely okay. This data may prove useful one day for some data mining or whatever, it doesn't matter. But we need to store everything like this. So we have a byte array here, and in order to use the database with a byte array, we need to convert the image to a byte array, which is not very cool, like we talked earlier, but hear me out. I just want to add the DB set here. So we have public DB set of image data, like this. So using byte arrays. Entity Framework doesn't support extracting streams from the database and getting the byte array as a stream instead of a byte array, but it's very easy to read the byte array as stream without Entity Framework, but it's easy. It's 5 lines of code. I don't remember it, but I have it in the presentation. It's not very difficult to read the byte array as a stream. So what we can do is we can write down the images in the database as byte arrays, and that's okay, because typically in web applications, people read a lot more than they write. For example, how many times you went to Stack Overflow to write something, and how many times you went to Stack Overflow to read something. So if we optimize the read, we can say that we are absolutely fine. Of course, if we want to not use byte arrays here and use streams, we can do that, but it will be way more difficult as a code. It will not be 5 lines of code. So in terms of development, I prefer to write everything as byte array until deemed necessary. But in terms of reading the images, I'm going to use the most optimized way possible, because most users just read. When I go to some website for car ads, how many times I look for cars and I look at their images, and how many times I post a car. So in terms of that, it's okay. Of course, when you see how I read a byte array, because I'm using a low-level DB connection. I'm not using Entity Framework to read the stream. When you see how I do it, you can imagine how it will look like to write as a stream, but it's more difficult. I tried to find an easy solution with Entity Framework or the DB connection class or whatever, but all of the solutions looked kind of too hardcore, and I believe it's not worth it. I really need to have the performance needs to start implementing in that way. In terms of development, that's the most important factor. Always consider that the development cost is the biggest cost in the team. So you always should try to use the easiest possible way to solve an issue, to solve a task, to write your code. Of course, following best practices, that's important in the long term. But you always try to use the easiest possible way. Like here, it's easier for me to use a GUID. It's easier than to implement cryptographic algorithms. It's way more easier. And if I see that I have a performance issue, because I understand that I have a performance impact here, if I see that I have a performance issue because I have a lot of images in the database, then I'm going to replace that. But I'm optimizing when I see that I have a performance problem. And that's super important in terms of optimization. Yeah, of course, it's good idea to know that I'm in a server environment. A lot of people will upload images, so I'm going to use asynchronous calls because it's not that difficult. Whether I'm going to add a task run here is 3 lines of code, so I'm going to add that. I may not need it in terms of performance, but it's very easy to do. But so I'm optimizing hard stuff to do only if necessary. Let's add this new GUID, otherwise Entity Framework won't be very happy. And the image data is here. The image data. So what I need to do now is I need to add a migration. Add migration image data table. Of course, if the images are, for example, by users or related to a post or related to an ad or whatever the business requirement is, in the image class I'm going to add foreign keys. That's completely okay. Public string user ID or public string post ID. After all, if I have a social network, I want to know that this image is for a particular post, or public int article ID and so on. You got the point. I'm just trying to keep the demo as simple as possible, and still it will take us maybe 4 hours to see everything. If you find yourself tired, or if you want to take a break, you can watch the recording indefinitely, so as you see fit. Good, cool stuff. Application DB context, I have a migration, and let's add a database migration here to be sure that the database is not making some wild things. I'm going to be functional. I don't know why I like chaining methods. It's not a good practice at all because how can I debug that? I cannot debug it. But it looks cool, so let's leave it. Cool. What we did, I explained about the IDs, I explained the GUIDs. We need to store the images. Now we have a problem here, and this is not related with our approach. It's how the DB context works. So if I make the following, first, what I want to do, I want to extract the byte array from the image. So I need to extract that. I already told you how to do it. We need a memory stream, new memory stream, which allows us to extract the byte array from a stream. Add it like this, and then return memory stream dot to array. This will return the byte array. We don't need the name parameter for now, and we need to return a byte array here like this. So I'm going to remove that, and remove that. And if I inject private read-only application DB context data, if I do that, I'm screwed because the DB context doesn't allow multiple threads to access and change its state, which means that consider that the implementation of task.run essentially means that it runs thread pool dot queue user work item. This is what it does behind the scenes. So it uses a different thread for each task, which means that this data object will be accessed from multiple threads at the same time, and Entity Framework doesn't like that. So we have some state here, and at the same time, a lot of guys will try to write to it, and Entity Framework just goes kaboom. It throws an exception saying that we are not allowed to use the database context in multi-threaded environment. We should have a single thread per DB context. That's the recommendation of Microsoft, and I cannot do anything here. I cannot change the lifetime scope of the DB context. I cannot say that it's transient, singleton scoped. It won't work. It won't work because this is how Entity Framework works. In a typical web app, you will have one thread per request. So this is why most of the time the DB context just works and it's happy with your code. But currently we have multiple threads in a single request because we convert images asynchronously. And the DB context is not happy. The solution to that is not using the DB context directly, but using iService Scope Factory. An interface which allows us to create scope for the service provider. So I can create DB contexts for each thread, for each task. I can create a separate DB context and it will work. So what I can do here is I can say var data equals this service scope factory dot create scope dot service provider dot get required service application DB context. Of course, if you want to follow best practices, we may wrap this interface to a something like scope provider, database scope provider, whatever. We can wrap that to make some decorator pattern to not use all of these methods chained like that, but that's not that big of a deal. We can do it if we want to be super perfect in terms of high quality. Otherwise, currently I'm creating a separate database context for each thread, so this works. This won't be a problem. And here I can use the image data as usual. New image data. The original file name is image.name. The original type is image.type. Original content is original. Thumbnail content is thumbnail, and full screen content is full screen. And then I can say await data.save changes async. And this should save and store the images in the database. Let's try it. Let's see whether everything works. Yeah, it's a bit tricky, but this is by Microsoft's recommendation. If you search the exception, which is multiple threads try to access the DB context, that's not allowed, you are a bad boy, blah blah blah. If you search the exception, you will find that they tell you, well, use service scope factory. This is why we introduced this interface. And I said, okay, I'm going to use it. The database is on WackelDB. The database is web server images. Let's run it like this, and I'm going to use the SQL Server Object Explorer to see the local DB because I don't care about the database. Of course, with local DB, the saving of the images is a bit slower than the full-blown enterprise SQL Server, but we don't care. I never use prop tap tap. Well, I said that we can argue about that. Most of the practices I follow are from the ASP.NET Core team. When I built my tools for testing, I played a lot with the source code of the ASP.NET Core, and this is how I got the practices I'm using everywhere, because I believe they know what they're doing. Of course, it has more instances, but one instance is not that much, especially instance which is used once and then disposed. The garbage collection of that is not super expensive. The thing I read earlier. Okay. Yep, of course, if you create your instances, if you create your services as singletons, even though they are stateless, I don't believe it's a mistake or something like that. Don't think that I found the research online that confirms my belief and that you're mistaken. I believe both approaches are okay, and maybe it doesn't matter that much. Maybe it doesn't matter. So I'm absolutely okay if on your team you decide to use singletons, then it's completely okay. Let's do it like this. It's fine. And if on some other guy's team they decide to use the services as transient because they follow ASP.NET Core the development team's practices, I believe that's also fine. So I guess it's one of those things that it's not correct or wrong either way. Uh, What this approach gives unit of work, it looks a little bit hacky. If you add a unit of work, or if you have a repository pattern and so on, it will still work. It's not a bit hacky. It's the official documentation. DB context, multiple threads. Docs. Mm, avoiding entity framework. Core doesn't support. I'm not sure whether I read this back in the day, but yeah, here it is. The add DB context method register DB context with scope lifetime, blah blah blah. Using dependency injection, this can be achieved by either registering the context as scoped and creating scopes using iService Scope Factory for each thread, or by registering the DB context as transient using the overload. I don't want to register the DB context as transient because the scoped DB context is the best lifetime for the DB context for the typical web request. For a web request where you have to fetch some data, then update the data, then save the changes and so on. But because we have a strange scenario here, an exceptional scenario, because I don't spawn multiple threads on every request. It's just on the upload to use the power of the server, because the hardware of the server may have 24 CPUs, like the server of Softuni, for example, and I would prefer to use this way. So yeah, it looks hacky. Of course, it looks hackier than injecting it directly. This is why I suggested wrapping it in an interface and make it look a little bit more prettier, at least. But it's the official recommendation in the documentation, so I guess it should be fine. Service locator pattern. The service locator pattern is the anti-pattern of the service locator pattern is the old school way of doing it, where you have a static object factory. You have a static object factory and you use it everywhere. So instead of using dependency injection, you use object factory dot create instance, and you provide the interface here, for example, iService Scope Factory. This is the anti-pattern using a static. This is super old school. This was done back in the day when I started developing. Some of the people still use the object factory. Otherwise, in the ASP.NET Core framework itself, they use the service scope factory, they inject that. They also have the service locator pattern there, because in some situations they need to create instances from static environments. So I guess in some situations it can be helpful. If you don't like that, if you don't like iService Scope Factory, if you hate that, what you can do is you can use a concurrent dictionary and store the images here in by using data structures instead of some other approaches. Instead of this approach, you can use dictionary of string and image result class or image data class, it doesn't matter. And you can make it concurrent. Concurrent. Like this, concurrent dictionary, string, image data. Let's stop it because the green lines make me nervous. And instead of writing to database directly, you can store the images in the dictionary, and then after the tasks are completed, then you can store all of these images from the dictionary in the database with a single transaction, because currently we have multiple transactions. But that's because I prefer to have a single transaction for each image, because if I have 10 images and one of them is corrupt, the other 9 I want to save them in the database. This is why I call save changes for each image. You can do that with the dictionary too. You can store each image separately if that's what is important. But nevertheless, you can just store in a concurrent dictionary. The string should be the name of the image, or what you can also do is you can use a GWT. You can also use a concurrent bag of image data. We can make the problem using data structures and save it. And this way you will not have to use a service scope factory. But both ways are okay. Both ways are correct. This one is actually the from the documentation of Microsoft. And keep in mind that you may run into the following problem every time you try to process multiple things at once, asynchronously. So you need to know how to save it. So it's a good idea to know that the service scope factory exists and use it only as a last resort, or just use concurrent data structures. It's completely fine too. Okay, so for the last time, if you don't like the service scope factory, good. I'm leaving it in the code because some of you may want to check the code in 2-3 weeks, or if in 2 months you need to process some images, you may decide to copy paste some code from here. So I'm leaving different notes so that you can know what you can do, because you may forget and so on. So instead of service scope factory, we may use a concurrent dictionary. Concurrent dictionary to get the image data and then store everything in the database with a single transaction, if you prefer to do a single transaction. Okay, let's save some images in the database and let's move on. I believe that everything here is completely fine in terms of implementation. Yep. Yeah. Isn't iService Provider a service locator? Yep. But iService Provider doesn't have a scope. If you try to request a DB context service like this, a DB context service from the iService Provider, it will throw an error because this is a scoped service and you don't have a scope. Of course, you can do something like what I did here. I made create scope, but yeah. So the iService scope factory is just a shorter syntax of using iService provider.createScope.serviceProvider. Agree about this? Probably I'll move the logic in another service which will be responsible for saving the data. Yep. That's a better separation of concern. Moving the logic to another service for saving data is absolutely the perfect choice. I'm not sure whether the probably is the right word here, because I believe it's the best approach actually. Set could be implemented. Yep. Okay, good. Oh, I'm super happy about the discussion. That we're talking about different problems, different solutions. We're considering all the different problems that can arise. I'm really happy about that because everyone is learning super much. So what we need to do is, yeah, save some images finally for the third time today. I'm a little bit slow because I couldn't sleep last night, so I slept like 3 hours maybe. So this submit, no exceptions, images uploaded. Let's check the server. We're maybe 70% done with the live class, so it's okay. It's not, we are not going to be super late. Local DB, web server images, not views tables, image data, view data. It should have some images with different contents. Looks okay. Good. So now what to do with getting images? Getting images is the straightforward, the easiest way is just getting the public task of iAction result, thumbnail, string ID, and we need to say something like this dot file, and in the image service I'm going to say remove the public. I'm going to say task from byte array. This is the straightforward solution. We are going to optimize it. Get thumbnail. Of course, we will have, oh, first we need to have all images. So the first method will be public task action result all this dot view, this dot image service dot get all images, because we need to list the images in a gallery. Get all images should return task from list of string. We need to get all the image IDs. That's what we care about. And the image service, in the get all images, that's super. Of course, now we should inject the DB context, but I'm going to reuse the service scope factory. It's not necessary. Okay, let's do it. Private read-only application DB context. Also, most probably, in a better written application, this won't be a single interface. This interface will be separated into 2 or 3 interfaces, for example, image processor service, image storage service, and so on. So it won't be necessary to inject databases this ugly. Get images, service code, this data, image data, select for each image. I want to get, of course, pagination and such should be applied, but we don't care about these details here. and I need to specify await. I need to specify async here, and that's it. Okay, back to the thumbnail. Back to the thumbnail, I have an ID, and what I need to do here is I need to say await this dot image service. Of course, this should be async. Image service get thumbnail by ID, and then I need to provide image/jpeg. So I need to say give me the byte array of the file and return it to the browser with the content type of image JPEG. And I need to do the same thing for the other full screen version of the image. I'm going to extract that method in a minute because we're going to add some additional optimization, but let's first implement these two, get full screen. Save image, get thumbnail. The straightforward solution here is to say data dot image data where image ID equals ID. Then we need to say select, give me only the thumbnail content, and then to say to list first or default async. Something like this. This is completely fine and this is completely okay, but like I said earlier, we can save the byte array conversion and we can use streams directly. This means that instead of making the following, I have a database, I have the server, and I say, give me the whole image as a byte array in the RAM, and then move the byte array to the browser. So again, I'm doing two steps with the middleman, the RAM being the middleman. Instead of doing this, I can say, hey database, give me a stream, give me zeros and ones, so that I can just stream them to the client. This way we optimize the memory and make it more efficient in terms of getting images. So we're essentially, the only overhead we have in the database is the query itself. Otherwise, once we find the image, we can stream it directly to the client. And that's the better approach. This works. This is completely fine. This is absolutely okay. But let me show you the better way. And the better way is with this code, which I won't be able to remember for sure. It's just working. I'm going to explain it, but I didn't want to waste time trying to remember what to do here. But so first we need to return streams from the image service. So instead of byte arrays, I'm going to return streams. We can see that the image controller still works because the returning file doesn't care whether it's a stream or a byte array as long as we provide the content type. So going back to the image service, we have a stream here, and let's see what we can do. This data. So get the database, then extract the database connection, then use a SQL command to extract from the database, select thumbnail, content, because I believe this is how I named it. Select thumbnail content from image data where ID equals ID, and I provide the ID as a parameter. It's not very difficult to use that, so this is why I decided to include it. Writing streams is a bit harder. And then what I need to do is just say return result, like this. So try to make the select statement, extract the thumbnail content, open the connection, read from the database, but read it as a stream. Look at this. Read it as a stream. If you read it as a stream, return it. This is the idea here. So we're working at a lower level than Entity Framework, and it's the same for the full screen. So I'm going to private stream async task of stream get image data string ID string size, and we can make it like this. I can provide the size here. And in the both get thumbnail, I can specify it. This get image data ID thumbnail, like this. And here it should be full screen. See how I didn't use async await here. This is to save the compiler from making a state machine for this task. So every time you can return a task directly and you don't need to await anything, you can skip it. Like here too. Instead of making async and await, which works, but this makes the compiler creating a state machine for this task, I can just return it and make the color of this image awaited. Write the await here. This is a good optimization of task-based programming. When you don't need to await something, don't await it. But here we don't have a choice. We want to return the data from the database to the view, so we need to await the result. Okay, so we did it here, and let's see what we managed to do. I'm going to add another area images all. So let's see what's going on. Okay, we don't have a view. Yeah, of course we don't have a view. We didn't create one. Model list string. For each var image in model, I want an anchor tag which goes to /images /full screen /image ID, and inside of it I would like to visualize the image thumbnail image, like this. Essentially I'm saying the server, hey, give me the full screen byte array of this image, and the server returns a stream and tells the browser that the content type is image/jpeg. And here I'm just rendering the image thumbnail. Let's see how that works. Hitting O and nothing works. Let's see why. We can see that we have status of 404. Invalid object name, image date. Let's see that. So I have images data, but I believe I named it image data. So that was one of the mistakes. And I believe that's the problem. Let's see again. These are working. So the links are working. The thumbnails are not. Let's see why. Maybe my URL is not okay or something else. Image, yeah. 3 hours of sleep. Guess it's normal. Yep, here they are. And we can see that the bigger images are working. But the problem here is that we're not optimizing the browser cache. Images are static resources. Most of the time, maybe 99% of the web applications, images don't change. At least this image with this ID won't change. I'm not going to come here and draw some mustache of this guy or something like that. I'm not going to do that. And when you upload an image on Facebook, for example, you cannot edit the image itself. It's still the same. Also, when you almost every single site, when you upload an image, you cannot edit it afterwards. So the image, the data of the image is static. So this means that once the browser gets the image, there is no point for this browser to request the image again. Not a single point. Because if the browser has the image in its cache, then it's irrelevant for this browser to call the server again for the image. That's completely unnecessary. It's making too many requests. For each refresh, I'm going to receive the same image. So if I put here in the images controller in the thumbnail, and if I refresh, I'm going to hit the breakpoint. And that's not very cool, even though the browser already has these images. Currently, the browser requests them every single time. And that's not optimal for sure. I'm not disabling cache, so the browser should have cache. I'm hitting refresh and I'm here again. So this is not okay. Images are most of the time static. So what we can do is we can leverage the browser cache and return information to tell him that we want the images to be cached by the browser. And this is done by adding two headers. Typically, it works with one header, just adding cache control public with the max age property. This essentially means cache this response for 30 days. If we add that, the browser will cache the image, but on some browsers, the expires header is also required, and some tools which validate whether the cache is working correctly. So this is why I'm adding two headers. So what we can do is we can get the code and we can say private iAction result get image string ID. Let's not make it string. It should be a stream. It's not get. Return image. and we can just say this return image without that and return image without that. So we leverage browser caching and optimize the images and server requests even more. Imagine that I just save 9 requests for each thumbnail. Even more if the user clicks on the image. And if I open, I can see that now the browser loads from memory cache. And if I put the breakpoint here, I can see that refreshing the page doesn't call the server. So I saved 9 requests for 9 images. If I have 30 images here on this page, and if I have 1000 users browsing the app, I'm saving quite a lot of requests to my server, and that's a lot of performance improvement, huge performance improvement. Of course, loading the image once will load it the first time, but then on a refresh, it should load it. It shouldn't call the server. Let's see. So currently loads the server because it's not part of because the top level request, the browser always calls it, the URL. This is, but if this image was visualized as part of an HTML like this, it will not call the server. We can see the headers. It has cache control header, it has expires header, so the browser will cache that if it's visualized in a web page. But currently, although if I take a look, it doesn't call the server right now, so it's working. But if I refresh, then it calls it. Yeah, okay, fine. If I refresh the top level URL, it will call the server, but otherwise it won't call it. Here it is. So currently I'm saving a lot of requests from the server. The user may decide to save the image and so on. Everything is from the browser cache, which is super optimized. And it loads fast because I've done everything as correctly as possible. The database streams the images. The images are not big. If we take a look at the image should be super small because the image is 300 pixels, it's not big. And when I open it, then I see the big image. And the quality is also okay for 1000 pixels. Good. I hope you liked this approach. I hope you liked everything I've shown you for now. I hope you learned some tricks with image processing. What we are left to do, again after a short break, I believe by 10:30 we are done, so it's not too late. The next thing we are going to show is storing images in the file system, the manual organization I mentioned, because there's a trick here we need to do. And finally, I'm going to show a sample code of what it looks like to store an image in the cloud, Amazon S3, but it depends on the cloud. It's not very difficult, it's just reading documentation. Again, using clouds is more expensive than self-hosted solution, and for average everyday apps, this solution is better. Let's see what you said. Good progress, probably pay attention mostly in image processing. Yep, when using cache control header with maxh or smaxh, then expire header is ignored. That's not always the case. Some of the older browsers require that. I've tested that for the system I've made with the images. So it sucks, but yeah. By the standard, by the HTTP standard, the expires header is ignored. I'm using this tool to test, not this tab. I'm using this tool to test all my sites. gtmetrics.com. It's it's a good testing tool. It tests from Canada, but we don't care about that. It will show us that the site is super slow. If we enter a Bulgarian site, it will show us that it loads for 10 seconds or something like that. But that's not always the case. The important part is not how fast the site is, but the recommendations which this GTmetrix tool will show us. For example, patreon.com is grade E. If we analyze all the details here and all the recommendations, performance, what we can do, it will tell us everything about images, videos, everything we can optimize. For example, they're saying that this JavaScript is a blocking resource, and we may save almost 1 second. Large network payloads. These are too big, I guess. But yeah, this site is great. You can learn a lot about optimizing websites. When you deploy a website, run it from here. This is how I learned everything about the optimization of the images. The expires header is something this site recommends for older browsers. This is why I added it. Otherwise, yeah, on Chrome you don't need it. On most of the browsers you won't need it. But nevertheless, I have to say that it's not fully supported. Okay, let's make another 5 minutes and we're going to check the storing images in the file systems, because we already set retrieving images, multiple results, how to retrieve multiple results, how to apply the headers, and I added the base64 format because most of the beginners, when they try to process images, they try to use base64 because it's easier, but base64 makes the images 3 times larger. Yeah, base64 format for images, it's easier to return to the browser, it's easier to use, of course, but makes the images 3 times larger. So it's not worth it, in my opinion. It's better to write this controller, which is written in what, 2-3 hours. And yeah, you can add some best practices in mind here and there, but nevertheless, this is absolutely okay for serving images. Good. Next thing is saving the images on the hard drive. It's mostly copy paste because we already did the hard part, but still we need to consider some problems that may occur. Good. Okay. 5 minutes again. Okay, let's continue. Continue here. Good. So what we need to do with the file system is we still need to have a table in our database, because most probably we need to save which image is for which article or for which post or for which user or whatever the business case is. So even though we're storing the images, the bytes, the zeros and ones on the hard drive, we still need to store the image data in the database in terms of the ID and to which users this image is connected and so on. So we need to have an image file class. Again, it may be called image data, it doesn't matter. I'm using different names to make sure that everything is different. Okay, so image file. What we need to store here is again an ID. Why I'm not using prop tap tap, don't know. Everybody asks me. This is the way I learned and never went back. Joking. I tried to learn it, but I guess it's a habit. So with the int here, it's the same case. So I'm going to put that. If we want to use IDs, it's completely okay. And if we want to use IDs with this approach, we can save a database code on each upload, but that's not that important because we just need to get the total number of images in the database, because we need to spread them throughout the folder. So the first thing we need to do is we need to store the ID and the folder. And it's important to know that if we use an integer as ID, the folder can be calculated. So that's not that important. I'm going to use a GUID again, but if we use an integer, the folder property is not required. We just need to add the other properties like public string user ID, public int article ID, and so on. Okay, application DB context, public DB set, image file, image files, get set. One more migration. And that's it. So going to images controller, the uploading here is the same. The image service, the name, the content type, the open, read, stream, and so on. Getting all images is also the same, almost. These two are no longer relevant, getting the thumbnail and the full screen, because they're on the file system and we can map that very easily. So if we want to use, I'm going to create a new controller. I'm going to say file images controller, because I don't want to change this code. I want to serve it as a demo if you want to copy paste in the future or whatever you want to do with it. So I'm going to use another controller with almost exactly everything the same. The index is the same, The upload is the same, the O is the same, the thumbnail and full screen are not. The returning of the image too. So this is what the controller will look like. Then I need a file image service. Which of course has the same methods without the two specific ones, because we are going to get the images from the file system directly. And I'm going to copy everything from here because it's pretty much almost the same. I just don't want to change the class. I want to have the two approaches in the same solution. Good. And finally, in the startup class, I want to say I file image service maps to file image service. And in the views, in the layout, I'm going to make sure that both are accessible. Good, 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 good. So the file images controller should use the iFile image service. Everything else should be the same. And we should add a view. First the folder, file images. The upload is the same. The done is definitely the same, and the O should be changed, but we're going to change that in a minute. Okay, so the file image service, what's the problem here? The problem is that we want to store every single image in the www root folder so that it's accessible. So we need to have, for example, images here. Because the www root folder is public, we want to store the images there, because we want our web server to call directly the static files on the server and not hit the MVC pipeline. Of course, if the images have some authorization behind them, we need to call the MVC pipeline, or we need to configure the Kestrel server to require authorization. But still, when we use the database, we hit the MVC pipeline, because to load the image, we need to hit the action thumbnail, which fires the action filters and so on. Then we call the service layer. We have some code here, which is not that bad. The MVC pipeline is super fast and super optimized, but still it's a small overhead. So on the file system, first we don't hit the MVC pipeline, then the file system, then we don't hit the database. We directly hit the file system, and the file system is indexed and is optimized thanks to the operational system. The only problem here is that if we store the images in a single folder, and if we have a lot of images in it, the file system will start becoming slower and slower, because indexing 1000 files, it's super slow. So the problem here is that we shouldn't store the images in a single file or in a single folder, because the more images we have, the more this file system folder will be slower. So the solution is to spread these images in different subdirectories in the images folder. So we need to create subdirectories and then store 100 to 1000 images in each folder. This way we again will have 1 million images here, but they will be optimized in terms of indexing on the file system. I guess you've noticed that on the file system of a Windows machine, for example, or on your own computer, I guess you've noticed that the folders which have a lot of files are more slower to index and to work with. So we want to avoid that problem here. And we need to avoid it with adding some code. First, what we need to do is we need to change the whole approach, because right now we don't care about the byte arrays. What we care about is, let me remove these, they are not important, and this is also not important. I'm going to add that in a minute. So, saving images. We are not interested in saving images and returning byte arrays anymore. We don't care about that. What we care is saving the JPEG on the file system. On the file system, but on a specified folder. I'm going to show you how we're going to calculate the folder. So, the JPEG async needs a path, and I'm going to provide the path here. This is everything we need to change to this method. Everything else is okay. So we resize the image and save it on the file system. The problem is what we do and how to calculate the folders. So the easiest way here, first we need to use, let's fix the database. It's image files and image file, and we need to provide an ID. I'm going to provide it in a minute. So the whole idea is like this. We're going to get the total images in the system, and we're going to find the remainder when we divide it by 1000. 1000 will be the folders which we want to create. So this way the images will spread throughout different folders depending on the total images in the system. So if we have one image in the system, it will the next ones will store them in the first folder, the first subfolder. If we have, for example, 3 images in the system, we will store the next images in the third folder. If we have 10,003 images in the system, we again will store them in the third folder. So by using this simple formula, we distribute every image in a separate folder, which makes the images folder a lot more faster. So the whole logic is get the ID of the image, get the path, which is /images, and the subfolder calculated by the formula, get the name of the image, which is JPEG, and then the storage path is the current directory matched with www-root and then the path. I need to replace these because they're not working, so I'm adding these two, and then I'm creating the directory if it doesn't exist, and I'm saving the 3 images in 3 different names: original name, full screen name, thumbnail name. So let's get that. here, and let's see what we have. First, we need to extract the total images. Total images is this dot data dot image files dot count async, like this. Good. Just a small mention, instead of total images, you can use the ID of the image here if you use the other approach with integers. So we can use the ID divided by 1000 and getting the remainder. Image file, file image service. Okay, so we have total images. We then have the image result. We get the ID. This is the path. This is the folder of the image. We have a name, which is the ID. Then we combine the path and replace the backslashes. If the directory doesn't exist, we change it. And full screen width. Like this. Storage path. Why I use that? Oh yeah. Because this is no longer needed, because that's the database requester. We have the name of the image and the path of the image, which should be combined here, I guess. So we calculate the data here, we calculate the folder, and by dividing by 1000 we spread the images to 1000 folders. We can divide by 100 if we want to spread them to 100 folders. That's the whole idea. Otherwise, this folder will become super slow in time. Okay, let me check the code again. So what we do here is we have the path, we have the name. We combine the path of the www root folder, then store the original name, storage path, the full screen name, thumbnail name, looks okay. In the database, what we need to do is we need to store the ID, the GUID we created earlier, because the GUID is important because it contains the file name on the file system. So we needed to create it, we needed it earlier, and then we have the path and get all images will just return image files, the folder, and something like that. Of course, we may need to add the thumbnail. Of course, we can add other methods which return not only the thumbnail but return the full screen, for example, but you get the point. The whole idea here is we store the images in distributed folders. We save the ID of the image and the path. So every time we try to request an image, we can extract it from the ID and the folder. And this is how we get it from the database. Let's see whether the code works. and whether we need to change something. What would you do if you have to generate the file? Let's say the file will be around 1 gigabyte. Where would you store it and why? It depends on the file. First, I would append line by line so that I don't have 1 gigabyte of memory in the file, in the RAM, in the memory. Yeah. So this is the first thing. I need to calculate and append it line by line, or at least in chunks, because if multiple users request 1 gigabyte of memory, the server will shut down very, very, very soon. 1000 folders, yeah, it's consider the fact that if you have 2 million images, you need to spread them. 2 million images in a single folder, it will be super slow. It will be super slow to index on the file system. And with 1000 folders, you will have 2000 images in a folder, and that's quite fast. In my toy exchange system, which I did, and I used the file system approach, I used this approach here, I had around 10,000 ads. Each of these ads had more than 10 images. So for a very small site, I had 100,000 images stored on the server. 100,000. So if I didn't spread them to 1000 folders, the site wouldn't work correctly. So this is important. Upload to file system. Let's see what's going on here. Let's submit that. Images uploaded, all from file system, and nobody here. Let's see what's not working. We have 0. So the images are here. Apparently the images were created. Let's add some other images. For example, I'm going to add one more image. And then I'm going to add, for example, 2 more images. And we're going to see that they're getting distributed to different folders, which is exactly the case. So the only thing we need to solve right now is why the URLs are not working. So I am asking for swash. Oh yeah, it's not working because we didn't fix the view. The view should be the view here in the file images is actually the whole image. Here it is, like this, because this is the path I'm directly getting from the database, the full path. At least if everything is working correctly. I'm calling get all images, which gets the folder, the thumbnail, underscore, which is, and then the ID, which is essentially what I have. So, and if I want to, I'm going to use a hacky solution. Of course, a better approach is to add a method to get the full screen. That's out of the question, but let's see what's going on. So swash images, 0 full screen. Yep. It's missing the extension. With this approach, the performance of the the performance of the images will be faster because we are skipping the MVC pipeline and we're skipping database calling, but we need to make sure that these images are backed, because in case of some failure, we don't have automatic backups. With database systems, usually we have. Usually the system administrator set up some sort of database backup, and that's completely, and it's working fine, because with the other approach, these backups make backups of the images too. The problem with the other approach is that the backups tend to grow quite larger because the images are inside the backups. But like I said, there is no perfect solution. Both solutions work well. We need to consider the disadvantages, and we need to make sure we work with them as optimized as possible. So what about the performance? Because performance and getting the images, because we cannot debug the static files in ASP.NET Core, but we can see that the browser is still caching them. Why? Because the server returns an ETAC and last modified, which essentially is another caching mechanism, but unfortunately it requires a round trip to the server. So we have a cache, but the browser calls the server. What happens exactly is that the browser calls the server and says, hey man, is this image changed? And the server returns not modified. So the browser doesn't download the image, which is still better than downloading the image every time. The browser doesn't download the image, but still asks the server whether the image changed. So we have half optimized solution. It's okay, but it's half optimized. It's better than requesting the images, but it can even be better. And fixing that is actually super easy. What we need to do is on the use static files middleware, we can just say new static file options. Then we can say on prepare response equals context goes to, and we can apply the headers we added earlier, but this time we're going to add them here. This thing, we can add it here. Of course, we don't have this. And okay, I hate double wording, so this should be options maybe, or preparation, or any other word that is not context. And yeah, okay, so of course this should be extracted to extension method. I really hate long startup classes. Everything should be extracted and should be neat and tidy. Super neat and super tidy. Like the demo code I show on every single project I have. Let me find a neat and tidy startup class. Use web service, initialize, add messaging, add web service, everything is extracted to services. If you want to take a look at this code, this is just microservice applications working in a Docker Compose environment. You may take a look at this repository, it's free. But yeah, so the static files should be extracted. This should be extracted, but pretty much we are done. Pretty much we're done with both solutions, with the database solution and the file system solution. Everything else, anything else? Not sure. Let's see what's going on here. Nothing much. And finally, what I want to show you is how it would work if we're using an external storage, which once again it's more expensive, but nevertheless 500 stories. Keep in mind that this is a project from 2015, so the code is not super, how to say, clean, maybe is the word, and this was a rushed project, so we don't care about best practices here, but pretty much we just need to read what to do with the Amazon. If we use Amazon, of course, we create Amazon client from some region. We need to provide some API keys to this thing. Then when we decide to use to store images, yeah, it's pretty much this. Memory stream, get buffer of the image, so get the byte array. I guess the Amazon S3 client should work with streams, so there is no need to read the byte array like I did here, but nevertheless, resize the image to smaller sizes, what we did here, apparently, 350 and 900, and just create two different streams and send them. So yeah, I can optimize that by removing the byte array here and just start resizing, but nevertheless. Then send the streams of the resized images, but you can see S3 client put object, the bucket name is the storage place. I'm saying this is the key, big image URL, which is the name of the URL, and this is the input stream. Big image URL is some GUID, you can see it. GUID, new GUID to string, substring, story ID, small path extension, quite an interesting algorithm, but nevertheless it works, it creates unique images. And then what I need to do is, if the status code is OK from the S3 client, I just need to store the image URLs to the database. And every time I need these image URLs, I need them to be visualized on the HTML, I just link to the Amazon URLs, and that's it. So of course a lot of the code can be extracted to services, can be improved in terms of clean code, but the whole idea is again the same. Resize the images, get the stream or the byte array, send it to the external cloud, get the response from the cloud, and the response should be some URLs. And if the response is OK, save the changes in the database to store the URLs, and every time you want to visualize that, you do it in the HTML directly. So we covered a lot. That was a 3 hours workshop, I believe. Only the data structures was longer, but nevertheless, I hope it was interesting. I hope I shared with you a valuable knowledge. I hope you learned new stuff, because all of these things were learned the hard way by me. 2 weeks I did image optimizing, image researching, how to make them better. 2 or 3 weeks I optimized the images back in the day in the toy exchange system, and this is why I believe it's a valid topic, because I save a lot of time just by introducing all these concepts. Otherwise you need to get all the information from different sources. You may not realize that the file system will start slowing down until you have a lot of images. Then you need to move all the images to subfolders to change the data. It's an interesting migration nevertheless. So I hope you really learned some of the tricks here. And you can take a look at the code helpers. Of course, as always, I'm going to uh, push the presentation and the source code on GitHub. I'm going to post it on Patreon, so you may play with it, you may copy some of the code, and that's pretty much it. If you don't have any questions, I will be waiting for 30 more seconds because the stream is like a time machine. You're seeing me a bit later. I'm glad, guys, that first I'm super glad that you entered in the discussion. We talked about different concepts, we learned new stuff, we uh, talked about the service locator, we talked about the life cycle of the services. This is why it's very good to have live feedback because we discuss different topics which some of the people may not know, and we expand the knowledge this way because I learned some stuff, you learn some stuff. It's super nice. So I'm super happy that more people are watching live. Most of the people who are on Patreon will watch the video on recording, but I guess they want to save more time or they don't have the nerves to watch 4 hours. And some of them are not from Bulgaria. This is why everything is in English. And more people are coming from other countries, which is also great. And maybe the hour of the live stream is not suitable for them. So, okay, thank you. I'm glad that you participated in the chat, and I'm glad that you liked the video and you liked the knowledge shared. I'm going to see you in 1 or 2 weeks because in December I want to finish earlier because for 6 months I haven't rested for a weekend and I need a serious vacation. Okay, guys, thank you. Bye, and I'm going to post the other videos soon. Bye.